You're cruising down the highway. A massive dump truck pulls alongside. You glance over and freeze. The wheels are spinning. The engine's roaring. The whole truck is moving forward. But one entire row of tires? They're not touching the road. They're floating, hovering in midair like they're defying gravity. Your brain screams, malfunction. You think the suspension is broken. The truck is about to collapse. But here's the thing. That driver isn't panicking. They're not limping to a repair shop. They deliberately lifted those wheels off the ground, and it's about to save them thousands of dollars. Here's why. Roads are fragile. Concrete and asphalt look tough, but they have a breaking point. Weight matters, but not just total weight. It's about how that weight concentrates. Think about walking in snow. Wear high heels. You sink immediately. Wear snowshoes. You stay on top. The weight spreads out. The same thing happens with trucks. A 20-ton load on 2 axles creates crushing pressure. The pavement breaks. Here's what really matters. There's something called the fourth power law. Double the weight on one axle, and the road damage increases 16 times over. Not double, 16 times. A single overweight truck can destroy pavement the same way thousands of cars never could. That damage costs money, lots of it. One violation? $10,000 in repairs. So engineers solved this problem. They created something called a lift axle. It's a third or fourth axle that sits underneath the truck, but here's the trick. It doesn't always touch the ground. When a truck is loaded with gravel or cement, the driver flips a switch in the cab. Airbags inflate underneath. Hydraulic pressure builds. Suddenly, that floating axle drops down and makes contact with the pavement. Instantly, the truck has more wheels. The weight spreads across more tires. The pressure on the road drops dramatically. The truck becomes legal to drive. The pavement survives. But if more wheels solve everything, why doesn't every truck keep them down all the time? Because every tire that touches the road costs money. Not just to buy, to run. When a tire rolls against pavement, it creates friction. That friction is called rolling resistance. The more tires you have spinning, the harder your engine works. The harder it works, the more fuel it burns. An empty dump truck with those extra axles down? The driver is burning fuel for nothing. Those tires are wearing out for no reason. Commercial truck tires cost $400 to $600 each. Now multiply that across a fleet. Hundreds of trucks, thousands of tires. If those tires are spinning unnecessarily, you're watching money literally roll away on the pavement. Studies show lifting those extra axles saves 3 to 5% on fuel consumption. For a trucking company moving thousands of loads annually, that's 6 figures in savings every single year. But there's another reason these wheels lift up. Money in a different way. Many highways and bridges charge tolls based on axle count. More axles touching ground. Higher fee. Lower axle count. Lower fee. A truck classified as a 3-axle vehicle might pay $100. The same truck with an extra axle down? $200. By lifting that extra axle, a driver legally reclassifies the truck. They cut the toll in half. It's not cheating, it's following the rules. But it reveals something important. The system itself rewards lifting wheels. Engineers didn't just solve a physics problem. They found a solution that saves money 3 different ways: fuel, tires, and tolls. Now here's where it gets interesting. Long trucks have a problem when they turn. Imagine a vehicle with wheels fixed to the ground all the way down its length. When it turns a corner, the rear wheels don't just roll forward and turn. They get dragged sideways across the pavement. This is called scrubbing. It sounds horrible because it is. Tires screech. Rubber shreds. The truck's frame and suspension experience massive stress. Too many wheels on the ground means the truck essentially refuses to turn. It wants to drive straight forever. This is catastrophic in cities. Construction sites with tight corners? Impossible. Residential areas? The truck can't navigate. Without lift axles, these situations become dangerous and destructive. The truck physically can't move where it needs to go. But here's where the lift axle becomes genius. When the driver lifts that extra axle, something magical happens to physics. The truck's effective wheelbase, the distance between front and rear wheels, instantly shortens. A shorter wheelbase means the truck pivots more easily around corners. Tight turns become possible. The truck transforms from a rigid straight-line machine into something nimble. It navigates city streets. It maneuvers through construction sites. The tires don't scrub. The pavement doesn't tear up. The suspension doesn't get destroyed. The truck became a shapeshifter. In highway mode, it's heavy and stable with maximum wheels down. In city mode, it's agile with wheels lifted. Same truck, Two completely different personalities, all with one switch. But this system can break, and when it does, consequences follow. Imagine a driver loads a fully loaded truck and forgets to lower the lift axle. The weight concentrates on just two axles. The truck is now significantly overweight. If that driver passes through a weigh station, sensors detect the illegal weight immediately. Fines start at $500. Could reach $3,000. But there's worse. Failure during driving. If the air suspension fails while the truck is fully loaded, the lift axle suddenly drops with all that weight on it. The impact stresses the frame. The suspension collapses. The truck becomes unstoppable, unable to brake properly. Catastrophic accidents happen. Drivers must understand this technology. They must respect it. It's not just about money. It's about safety, about preventing disasters on crowded highways. Now zoom out. Think about the scale. Thousands of trucks on American highways alone. Millions globally. Every single one uses lift axles strategically. The collective impact is staggering. Government budgets for road repair? Reduced significantly. Pavement lasts years longer because weight distributes properly. That's billions in infrastructure savings. Your tax dollars stretch further. Trucking companies save millions annually on fuel and tire replacement. Those savings get passed down. Shipping costs decrease. Consumer prices drop slightly. Environmental impact? Reduced fuel consumption means less carbon emissions. Millions of tons of tire waste prevented annually. The ripple extends internationally. European trucks use similar systems with different regulations. Australian road trains employ massive configurations. Asian highways adapt the technology to local needs. This isn't just American engineering. It's global infrastructure intelligence evolving in real time. Smart systems emerge. Sensors automatically adjust axles based on load. Predictive algorithms optimize when to lift and lower. The technology continues evolving. Next time you're on the highway, look closer at those dump trucks and cement mixers. You'll see them everywhere now. That hovering wheel isn't a ghost. It's not a malfunction. It's calculated intelligence. A truck adapting in real time to physics, regulations, and economics. But here's what's strange. Lift axles solve one problem perfectly. Yet there's another truck feature that seems equally broken. Something that makes engineers deliberately misalign wheels on purpose. And the reason why will blow your mind.